take this as your take this as your exercise for the last video. Take this as your classwork for that last video we did. So let's move forward. Now we are going to move to question 9 in the exercise. It says, consider the following redox reactions. Name the substances that are oxidized. Name the substance that is oxidized, reduced, the one that is the reducing agent, and the oxidizing agent. These are simple questions. Let me just jot down my title. So finding reducing agent. Okay. Finding reducing agent. Excuse me. This will not waste our time. I'll be fast. Finding reducing agent, oxidizing agent. Finding reducing agent, oxidizing agent, etc. Let me just put it that way because of time. etc. in a redox reaction. In a redox reaction. So let's go. Number 9. In question A, the reaction is, what's the reaction in question A? Lead oxide plus hydrogen to give lead plus water. Lead oxide plus hydrogen to give lead plus steam. Gas, solid, gas, solid. Now in this question, let me jot down what we have to find first. In this question it says, first we should find the oxidized reducing agent. We should find the oxidized agent, the substance oxidized. We should find the substance oxidized. We should find the reducing agent. 3. It also says we should find what substance is reduced. We should find what substance is reduced and the oxidizing agent. We should find what substance is reduced and also find the oxidizing agent. This is very simple. Let's just take it one after the other. I'll write the equation again. Lead oxide plus hydrogen gas to give lead oxide plus hydrogen gas to give lead plus what? Steam. Now in this question, first thing we do whenever we have a question like this is to write the charges under each element. Oxygen does not change. It is the same on the left and right, -2, -2. So we don't need to write oxygen. But for others, there are changes. So lead is the oxidation number of lead is +2 in lead oxide, because this is the same as lead 2 oxide. The oxidation number of hydrogen here is 0. It's a lone molecule or lone element. The oxidation number of lead here is 0 on the right, and that of hydrogen here is +1. So you will notice here that the oxidation number of lead has reduced from +2 to what? To 0, and that of hydrogen increased from what? 0. That of hydrogen increased from what? 0 to +1. In water, the oxidation number of hydrogen is +1, but here the oxidation number of hydrogen is 0. In lead oxide, the oxidation number of lead is +2, but here where lead is alone, its oxidation number is 0. So that means I can label my lines. This is a decrease in oxidation number from +2 to 0. So that's a what? A reduction. A decrease in oxidation number is a reduction. Also, this one is an increase in oxidation number from 0 to what? To +1. So that's a what? An oxidation. So that means That means if I separate the two, okay, I don't even need to separate them so that it will not take too much of our time. I'm just looking for, okay, let's continue. So the first question says we should pick what substance is oxidized. Here, hydrogen has its oxidation number changed from 0 to what? +1. So hydrogen was oxidized. You understand? Hydrogen is the substance oxidized because its oxidation number increased from 0 on the left to +1 on the right. I hope you can see that. Never mind that this is water, but oxidation occurred to hydrogen. Hydrogen got oxidized when its oxidation number changed from 0 to +1. So take note of that. Let's go to the next question. Okay, Roman number 2. It says we should pick in that reaction what substance is the reducing agent. Any substance oxidized in a redox reaction is the what? Is the reducing agent. So let's just make this complete. Hydrogen is oxidized. Hydrogen is the reducing. Hydrogen is oxidized. Hydrogen is the reducing agent. Hydrogen is oxidized. Hydrogen is the reducing agent. Also, let's go find the substance or agent that is reduced. Now, lead oxide. The oxidation number of lead changed from what? +2 to 0. That's a decrease in oxidation number, and that is a what? That's a reduction. Oxidation number of lead changed from +2 to 0. +2 to 0 is a decrease. So a decrease in oxidation number is a reduction. That means lead oxide was reduced. You will not say lead was reduced. Lead oxide, the substance in which that lead is present, is the substance reduced. So lead oxide was reduced. Also, what is the oxidizing agent? Lead oxide is the oxidizing agent. So any substance reduced in a redox reaction is the oxidizing agent. Any substance oxidized is the what? Reducing agent. So take note of that. Let's go to question B. Number 9B. Zinc, okay, 2HCl, okay. 9B, I'll be faster now. Zinc, okay, 2HCl aqueous to give ZnCl2 aqueous to give ZnCl2 aqueous plus hydrogen gas. This is 2. Take note. Now, in this reaction, let's just fix their charges. Zinc is 0 here, but here it is +2. Because chlorine is -1 times 2, -2. So -2 plus 2 will give you 0. That's how we got a neutral molecule. Here also, hydrogen is +1. +1 minus 1 gives you 0, a neutral molecule. But here on the right, hydrogen is 0. You understand? Because it's alone. Its oxidation number is what? 0. So zinc went from 0 to +2. I think that's an oxidation. Am I right? Hydrogen went from +1 to 0. Let me separate them. That's a what? +1 to 0. That's a reduction. So that's a reduction. So the question says, first we should write what substance is reduced. The substances we should write what substance is oxidized. What substance is oxidized here? We said the oxidation number of zinc went from 0 to +2. So zinc is oxidized. Zinc is what? Oxidized, because its oxidation number changed from 0 to +2. Can you see that? The oxidation number of zinc changed from 0 to +2. So zinc is oxidized. Okay, that means zinc is the reducing agent, because it is the reducing agent that gets oxidized. Are you getting what I'm saying? Question C says we should find what substance is reduced. If you check this very well, hydrogen has its oxidation number reduced from +1 here to what? To 0. +1 on the left here, but 0 on the right here, because in HCl the oxidation number of hydrogen is +1. But we are not going to say that hydrogen was the substance reduced. We will mention the whole substance. We will not just say hydrogen was reduced. We won't just say hydrogen was reduced. We will mention that HCl is the substance reduced. So in our answer, we are going to write HCl is what? Reduced. And D, HCl is the what? The substance reduced is the what? Oxidizing agent. HCl was reduced and HCl is the oxidizing agent. Let's go to question C. Oh, sorry, I've been writing A, B, C. This is question B. I should have written Roman numbers 1, 2, 3, 4. This is a more correct number. I'll be faster now because of our time. So let's go. In question C. What's the equation in question C? Okay, 3Cu 8HNO3. 3Cu plus 8HNO3 to give, I will not be putting the states anymore because of time. 3CuNO3 okay, to give 3CuNO3 plus what? Plus 4H2O plus what? 2NO plus 4H2O plus 2NO. I think this is clear enough. I should have. Let me try and squeeze everything into one single row, so it will not confuse us when we're writing the answers. Let me try and squeeze everything into one single row. Let me see if I can do that. C, 3Cu plus 8HNO3 to give what? To give, okay, is this 2 or 3? Okay, 2CuNO3 to give CuNO3 plus 4H2O plus how many NO? Plus 2NO plus 4H2O plus 2NO. Okay, I think I did this better now, so that we won't have them on two lines. Let's go. Here, copper is 0 here. The oxidation number of copper is 0 on the left. The oxidation number of nitrogen, this is triazonitrate 5 acid. So the oxidation number of nitrogen is +5 here. Hydrogen is not going to change. +1 here, -2 here. You understand? +1 in water, -2 here too. The oxygen here too is -2. So oxygen and nitrogen don't have their oxidation number changing, so we don't need to write them. I think the only things changing in oxidation number are just the copper and the nitrogen atoms in each compound on the left and right. Here, this is 0. Here, this is copper 2 triazonitrate 5. So the oxidation number of copper here is what? +2. Can you see that that's a change? Here, this is nitrogen 2 oxide. So the oxidation number of nitrogen here is what? +2. Every other atom has its oxidation number constant. Oxygen is -2 here. Hydrogen is +1. On the right hand side too, throughout, oxygen is -2. Hydrogen is +1. So we don't need to bother about the oxidation number of particles or atoms that did not change in oxidation number. So we now know what was oxidized and reduced. Copper is oxidized, and what? Nitrogen is what? Reduced. Can you see my lines? Copper got oxidized, nitrogen got reduced. So this is an oxidation. This is a what? an oxidation, and this is a what? A reduction. So let's go. What substance got oxidized? The substance that got oxidized is Cu. So what substance is the reducing agent? The reducing agent in this reaction is copper, which got oxidized. Also, what substance got reduced? Now, nitrogen atom reduced in oxidation number from +5 to what? To +2. That's the reduction. But when picking our substance, when picking our answer for the substance that got reduced, we will not say nitrogen. We won't just say nitrogen. We will say triazonitrate 5 acid got reduced. Are you getting what I'm saying? So the substance that got reduced is HNO3, and that same substance is the reducing agent. Sorry, that same substance is the oxidizing agent in that reaction. So oxidizing agent, you understand, gets reduced. Reducing agent gets oxidized. Can you see what I just showed you? The oxidizing agent in a reaction gets reduced, and the reducing agent gets oxidized. So the substance that is oxidized in a chemical reaction is the reducing agent in that reaction. Also, the substance that is reduced in a redox reaction is the what? Oxidizing agent. So that's what this exercise is all about. Let's go to the next question. Okay, 2H2S plus SO2. That's going to be easy. That's question D. 2H2S plus SO2 to give you what? 2H2S plus SO2 to give I'll try and be faster now. 2H2S plus SO2 to give 3H2O plus 3O. Okay, I think that was 2H2O to give 2H2O plus what? 3SO2. Am I right? Okay, plus 3S to give what? To give I don't want the S to touch the 3. Okay, I think that's better. Now let's look at our reaction very well. In this chemical reaction, hydrogen is +1 on the left, +1 on the right, so we don't need to put hydrogen. Do you understand? We don't need to number the hydrogen. But the sulfur here is what? -2. There are two sulfurs in this reaction. The sulfur on this left hand side here has a charge of -2. This one is sulfur 4 oxide, so sulfur is +4 here. On this side, the sulfur here has a charge of 0. It's alone, 3 sulfur atoms. So this is what? This is an oxidation. This is an oxidation. Let me use a different color to make it clear. This is an oxidation. We call this an oxidation because it's an increase in oxidation number. A change from -1 to 0 is an increase in oxidation number. So that's an oxidation. But on this side, this change is from +4 to what? 0. This is a reduction. This is not an oxidation, but a what? A reduction. This is a reduction. So we know where our oxidation took place now and where our reduction took place. Let's now go ahead and figure out our answer. The question says, what substance is what? Oxidized. What substance is oxidized? Here, the charge of sulfur changed from -2 to what? To 0. You understand? That's where oxidation takes place. But the substance oxidized is going to be hydrogen sulfide. You know what I said before? You will not just say sulfide is oxidized. You will say hydrogen sulfide is oxidized. More correctly. Is that clear? Also, what substance is the reducing agent? H2S is the reducing agent. The substance that got oxidized is also the reducing agent. I hope you can see that. Now, Roman number 3 says, what substance is reduced? What substance is reduced? Here, the oxidation number of sulfur changed from +4 to what? To 0. From +4 to 0. So that's a reduction. But when telling the substance that got reduced, we will not say sulfur. We will say SO2. Sulfur 4 oxide got reduced. And what substance is the oxidizing agent? The substance that got reduced is also the oxidizing agent. So SO2. What substance got reduced? SO2. What substance is the oxidizing agent? SO2. So the oxidizing agent gets reduced. Take note of this. It's not technical at all. Question E. Question E. MnO2 4HCl, MnCl2 2H2OCl2. Okay, let me write that quickly so that I can go for prayer. MnO2 4HCl to give what? MnCl2 2H2, MnCl2 2H2O plus Cl2 plus Cl2. So here now, quickly, let me put the charges there so you can see. Here, the manganese is +4. Here, this chlorine is -1. The manganese here is +2. The oxidation number of manganese in this compound is +2. And that of chlorine here is 0. The oxidation number of chlorine here is 0. So if you look at this reaction very well, this is a reduction. From +4 to +2 is a reduction. But this is an increase from what? From what? -1 oxidation number to 0. So this is an oxidation, while this is a what? Reduction. Take note of that. This is very essential that you know how to pick which substance or atom gets oxidized or reduced in a redox equation or in a redox reaction. So MnO2 goes to MnCl2. That's a reduction. The first question says that we should pick what substance is reduced. We should pick what substance is oxidized. Let me check again. Our first question is that, we should pick what substance is oxidized. In this reaction, what substance is oxidized? HCl is oxidized because it is in HCl that the oxidation number of chlorine changed from -1 to what? To 0. It's in HCl that the oxidation number of chlorine changed from -1 to 0. So the substance that goes oxidation in this reaction is HCl. Now, what is the reducing agent? HCl. You understand? The reducing agent gets oxidized. The reducing agent gets oxidized. So the substance that got oxidized in this reaction is also HCl. Roman number 3. It says we should pick the substance that got reduced. Now, reduction took place on manganese. Manganese got reduced, from +4 in manganese 4 oxide to +2 in manganese 2 chloride. So that's where reduction took place. So the substance that got reduced is what? MnO2. And that same substance is the oxidizing agent in this reaction. So the oxidizing agent is MnO2. So take note, in a redox reaction, the oxidizing agent gets reduced. In a redox reaction, the oxidizing agent is also the agent that gets reduced. The oxidizing agent gets reduced, and the reducing agent also gets oxidized. The oxidizing agent gets reduced, and the reducing agent gets oxidized. So take note. We'll be using that very, very often now. Our work as we go on with electrochemistry and in other parts of chemistry too. We'll take the remaining examples in the next video.